Hello everyone. Today we're going to learn about the different powers of I and how to simplify, as well as how to do operations with complex numbers. So here we have a chart from I raised to the 0 exponent all the way to the 7th, just so that we can establish a pattern. I raised to the 0 is 1, and that's because anything raised to an exponent of 0 is always 1. Now I to the first is just I. I squared, we learned in the past, is -1. Now, if we continue to find I to the third, that means that I to the third is equal to I squared times I. Now, since I squared is -1, then that's -1 times I, which is -I. If I continue I to the fourth, that means that it's I to the third times I. I to the third we know is -I. And if I multiply another I, then that would give me -I squared. Now since I squared is -1, then negative times -1 is equal to +1. And we have restarted the pattern. So we start with 1, I, -1, -I, and then back to 1. So I to the fifth would be I to the sixth would be -1, and I to the seventh would be -I. Now, if I had asked you to simplify I to the 502, you can certainly follow this pattern, but to get all the way to 502 would take forever. So instead, there is a way to simplify your powers of I. If we notice that this pattern resets after every 4. So what we do is we take the exponent and we divide it by 4. 4 goes into 5 one time. And we have to do long division here. Bring down the 0. 4 goes into 10 2 times to give you 8. 10 minus 8 is 2. We bring down the next 2. 4 goes into 22 5 times. And so then 20 minus 2 is 2. Now what we're looking for here is the remainder. It doesn't really matter that it goes into 125 times. What matters is the remainder. And this is because I raised to the 502 is equivalent to I raised to the remainder, which is 2. So I squared we know is -1. Therefore, I to the 502 is -1. Let's try that out with a couple more examples. Here we have I to the 38. So we take that exponent and we always divide by 4. 4 goes into 38 9 times to give you 36. And here we have a remainder of 2. Therefore, I to the 38 is equal to I squared, which is equal to -1. Let's try with I raised to the 99. Again, we take the exponent and we divide by 4. 4 goes into 9 2 times to give you 8. 9 minus 8 is 1. Bring down the 9 and we get 19. So 4 goes into 19 4 times to give you 16. And 19 minus 16 is 3. Therefore, the remainder is 3. So I to the 99 is equal to I third. And I to the third, as we already saw, is equal to -I. So really, all you have to remember is I squared and I to the third, because anything else, we already know that I to the first is just I, and I squared is -1. Let's try this with C. I to the 65th. So we're going to take 65 and divide by 4. 4 goes into 65 6 one time. 6 minus 4 is 2. Bring down the 5. 4 goes into 25 6 times. And 25 minus 4 is 1. So this is a remainder of 1. That means that I to the 65th is equal to I to the first power, which we know is just I. And now finally, I raised to the 100 if we divide 100 by 4, 4 goes into 10 2 times to give you 8. 10 minus 8 is 2, bring down the 0. 4 goes into 25 times, and here we get a remainder of 0. So this means that I to the 100 is equal to I to the 0, which is just 1. So anytime you don't have a remainder, the answer will be 1. Now let's start looking at operations with complex numbers. We're going to start with adding and subtracting. Now we have parentheses around the complex number, but if you're just adding, you can remove those parentheses. So for example, 3 plus 2i, and I'm going to add the complex number -1 minus 3i. This is the same as saying 3 plus 2i plus -1 is just -1 minus 3i. And now we combine like terms. Remember that complex numbers are always written as a plus bi, the real part and then the imaginary part. So I'm going to first combine my real parts, 3 minus 1 is 2, and then combine the imaginary parts. 2i minus 3i is -i. When you're subtracting, you have to actually distribute the negative. So 4 plus 7i minus 2 plus 3i is equivalent to 4 plus 7i minus 2 minus 3i. And now we combine like terms. 4 minus 2 is 2, and 7i minus 3i is plus 4i. Let's do another example. 5 minus 11i plus 7 plus 4i. Here we just combine. So 5 plus 7 is 12. And -11i plus 4i is -7i. Here, since I'm subtracting, I'm going to distribute the negative. So -5i plus I minus -11 minus 6i is equivalent to -5 plus I plus 11 plus 6i. And now we combine like terms. -5 plus 11 is 6, and I plus 6i is plus 7i. So that's adding and subtracting. Let's have a look at multiplying. When you're multiplying complex numbers, especially if you have a binomial, like a binomial times a binomial, you have to remember to FOIL. And you're just going to treat I like you would any other exponent. But your answer is never final until you have simplified all powers of I. So if you ever have I squared, you know you need to replace it with -1. If you have I to the third, you know to replace it with -I, and etc. So here we're going to multiply. We're going to distribute the 4. So 4 times 3 is 12. And 4 times -5 is -20i. Now we're going to distribute the 2i. 2i times 3 is plus 6i. And 2i times -5i is -10i squared. So here we can combine these two terms. So 12 and -20i plus 6i is -14i. Now -10i squared, this is the equivalent to -10 times -1, which -10 times -1 is plus 10. So 12 plus 10 is 22, and then minus the 14i. For B, we have 4i times 3 minus 5i. So I'm just going to distribute the 4i. 4i times 3 is 12i, and 4i times -5i is -20i squared. And remember, I squared is -1, so this is equivalent to 12i minus 20 times -1. And -20 times -1 is a positive 20. So now remember, we must write our complex numbers in a plus bi form. So the answer here would be 20 plus 12i. This next one, we're going to FOIL once more. So we're going to distribute this 7. And here we get negative 14 minus 35i. Now I'm going to distribute the negative 3i, which would give me plus 6i plus 15i squared. Remember that this is equivalent to 15 times negative 1, which is equal to positive 15. To negative 15. So negative 14, negative 35i plus 6i is negative 29i, and then minus 15. So we just combine those real parts. Negative 14 minus 15 is negative 29 minus 29i. For this next one, we have 3 factors. We have 2 times 3 plus 4i times negative 3 minus I. Now it's important to note that when you're multiplying 3 things together, you can only multiply 2 things at a time. Okay, so you can either choose to multiply the 2 with the 3 plus 4i, or you can multiply the 3 plus 4i with the negative 3 minus I. It doesn't matter which order you choose to multiply, as long as you're only doing 2 at a time. So I usually just like going in order. So I'm going to distribute the 2 into this factor. And that would give me 6 plus 8i. And now I'm going to multiply that with negative 3 minus I. So I'm going to distribute the 6. And that would give me negative 18 minus 6i. Now I'm going to distribute the 8i, which would give me negative 24i minus 8i squared. Remembering that I squared is negative 1, this is equivalent to negative 8 times negative 1, making it a plus 8. So if you notice a pattern, whenever you have I squared, what it does is it just changes the sign of your number. So negative 20i squared will become plus 20, negative 10i squared is plus 10, and positive 15i squared is negative 15. So you can kind of use that shortcut if you'd like. Now we're just going to combine like terms. So negative 18 plus 8 is negative 10, and negative 6i minus 24i is negative 30i. Now let's have a look at dividing. That's our last operation. Now when we're dividing complex numbers, we're not actually going to divide. What we're doing here is called rationalizing. Now the reason for this is that when you have I in the denominator, I, remember, represents the square root of negative 1. And we can never have a square root in the denominator. So, and also, if you think about it, I is not a real number. So if you have a fraction, remember that fractions are parts of a whole. And if we have an imaginary number in the denominator, that's not a whole number. So we're trying to make this into a whole number. Now we have 2 scenarios. We have when we are looking at a fraction or when we're dividing a complex numbers, and we have a monomial in the denominator. A monomial, please remember, is one term. So we only have a purely imaginary number in the denominator. Now how we turn that into a real number is you're just going to multiply I over I. Anything divided by itself is 1. So really all I'm doing here is multiplying by 1. I'm not actually changing my number, I'm just changing what it looks like. So when we multiply I over I, what we get is 3i over negative I squared. Now 3i is just 3i, but negative I squared is negative 1. So this would give me 3i over 1, which is just equal to 3i. So now we no longer have an imaginary number in the denominator. Over here we have 4 minus 2i divided by 2i squared. Again, this is just a monomial, so I'm going to multiply by I over I. And what I'm going to do here is I'm going to distribute the I in the numerator. So that would give me 4i minus 2i squared over 2i squared. Now when we work this out, remember that I squared is negative 1. So what this is becomes negative 2 times negative 1, which is plus 2. Remember, complex numbers, real plus imaginary. And all of this is getting divided by 2i squared, which is 2 times negative 1, so negative 2. In order to simplify this, because this is not quite done, what you can do is separate your fractions. Everything is divided by negative 2. So this is equivalent to 2 divided by negative 2 plus 4i divided by negative 2. 2 divided by negative 2 is negative 1, and 4i divided by negative 2 is negative 2i. Now over here, same thing. I'm going to multiply by I over I. I'm going to distribute the I in the numerator, and that would give me negative 3i plus 10i squared. And this is going to be over negative 6i squared. Now remember, 10 times I squared is the same as 10 times negative 1, so this is negative 10. And negative 6 times negative 1 is equal to a positive 6. So I can rewrite this as negative 3i minus 10, and everything is divided by 6. So I'm putting them both individually over 6. Now remember, we're going to write our real part first. So this negative 10 over 6, which can be simplified both the numerator and the denominator by 2, which is negative 5 over 3, minus, and now 3i over 6 can be simplified to 1/2 I. Now you can choose to put the I in the numerator, or you can put it off on the side. They're both the same. Let's look at when you have to divide complex numbers when the denominator is a binomial. Now when you have a binomial in the denominator, you have to take an extra step. What you have to do is multiply by the conjugate of the denominator. And we do that because when we multiply a complex number with its conjugate, it's going to turn into a real number. So a conjugate is when you take that middle sign of the complex number and you switch it. So for example, if I had negative 7 minus 5i, the conjugate would be negative 7 plus 5i. We only change the middle sign. So here I have 7 plus 4i divided by 2 minus 5i. So what I'm going to do is multiply by the conjugate of the denominator, which is 2 plus 5i. And you have to do that to both the numerator and the denominator. Now here, because this is a binomial, you're going to have to FOIL both the numerator and the denominator. So we're going to distribute the 7, and then we're going to distribute the 4. And what we get here would be 14 plus 35i plus 8i plus 20i squared. And in the denominator would be 4 when I distribute the 2 plus 10i, and then minus 10i, and finally minus 25i squared. Now if you've multiplied correctly, every time you multiply the conjugates, those middle terms will cancel out. See, I had a positive 10i minus 10i, so they canceled. Now here we're just going to simplify the rest of this. Remember that 20i squared is just now negative 20. You just switch the sign because it's 20 times negative 1. And negative 25i squared is negative 25 times negative 1, so this would be plus 25. So now when we work this out, we have 14 minus 20, which is negative 6, and then 35i plus 8i, which is plus 43i. Everything is divided by 4 plus 25, which is 29. Remember, since our complex numbers are written as a plus bi, we have to separate these fractions. So that way we have the the real number plus the imaginary. So I'm going to put the negative 6 over 29 and the 43i over 29. and this would be my answer. For 5 minus 2i over negative 3 plus I, I'm going to multiply by negative 3 minus I to both the numerator and the denominator. Remember, we're going to have to FOIL now. I'm going to distribute this 5 and then distribute the negative 2i. And that would give me negative 15 minus 5i plus 6i plus 2i squared. And this is going to be over negative 3 times negative 3 is 9. Negative 3 times negative I is a plus 3i. Then I times negative 3 is negative 3i. And finally, I times negative I is negative I squared. So remember that 2i squared is now negative 2, because 2 times negative 1 is negative 2. And then this negative I squared is negative times negative 1. So this makes this a positive 1. And again, since I multiplied my conjugates, these middle terms cancel out. So now in the numerator, for my real number, I have negative 15 minus 2, which is negative 17. And then negative 5i plus 6i is just plus 1i, so plus I. And finally, in the denominator, all we have left is 9 plus 1, which is 10. So I'm going to put both of my terms here over 10. So this is an acceptable answer. But if we're writing it in that a plus bi form, we would say negative 17 over 10 plus 1 over 10 I. See how it's a plus b and then I. So this would be a more accurately written answer. Last one here, we have 1 plus 2i divided by 4 minus 5i. So I'm going to rationalize by multiplying the conjugate, which is 4 plus 5i. And now we're going to FOIL. So I'm going to distribute the 1 and then distribute the 2i, and that would give me 4 plus 5i plus 8i plus 10i squared. And in the denominator, I would have 4 times 4, which is 16. 4 times 5i plus 20i. Negative 5i times 4 is negative 20i. And negative 5i squared plus 5i is negative 25i squared. Now this 10i squared becomes minus 10 because it's 10 times negative 1. And negative 25 times negative 1, because of the I squared, becomes a plus 25. Additionally, these 20 i's here will cancel out. So in my numerator, I have 4 minus 10, so negative 6. And then 5i plus 8i is plus 13i. Then when I add 16 plus 25, I get 41. So I'm going to put both of my terms here over 41. And those are your operations with complex numbers.